and I can measure how much time has passed by how much water goes into the vessel. Now, of course, I would have to calibrate this, and so I might calibrate things in milliliters, which is what this measures. And I'm just going to stop it right there. So that's about 100 milliliters. And so 100 milliliters is going to correspond to something like 10 seconds.
Thanks for watching. If you enjoyed this video, please hit the subscribe button and ring the notification bell so you never miss an update. Leave a comment below to help grow the channel, and don't forget to smash the like button.
So welcome back to Lecture 2. This lecture is titled, How Do We Know What We Know? And the short answer to that question is measurement. So in physics, we measure things. And we're really only concerned with things that we can measure. So what are the things that we can measure? Well, we can measure length occurring in space. Right? You're probably all aware that we live in a three-dimensional space, which means that we have to measure things using three rulers. One for up and down, one for side to side, one for forward and backwards. What are those rulers? And rulers have been around for a really long time. The first mathematics was done by the Greeks, and they used straight edges, which were kind of like rulers, and they used compasses, which were more like rulers for them than they are for us today. Space is pretty easy. We're all familiar with it, right? A person may be 6 feet tall, or they may be 5 feet tall, and we know what that means. It's not really ambiguous or a difficult concept to grasp. And it wasn't for, ancient people either. The other thing that we can measure is time. This one has been something that people puzzled about for a long time, because unlike space, right, which we can move forwards and backwards through, we cannot move backwards through time. We can only move forwards through time, and we really don't have any control over how we do that. And that has always been a bit of a puzzle for people, and it still kind of is, though we have a little more insight into it, but we're not going to talk about that now. And finally, just want to mention another kind of fundamental quantity to physics, which we'll talk about later in later lectures, is mass. Not to be confused with weight. We'll distinguish between weight and mass in a later lecture when we talk about forces. But mass is this kind of intrinsic resistance to motion that an object has. For example, a really heavy object, like a boulder, I would find really hard to push, whereas a small object like a little pebble would be very easy for me to push. And we can characterize this thing's kind of resistance to motion with this quantity mass. And you probably say, well, we measure mass using a scale, right? Well, scales would work today here on Earth, and they would give us a good estimate of mass. But a more reliable way to measure things is with a balance, like what I've drawn here. And the general idea is that we come up with a standard. We get a block, and we say this block is equal to a kilogram. And we use that as our kind of reference point. And with a balance where these arms are divided right in the middle, if the other object of unknown mass is exactly the same mass as this, then it'll balance out perfectly. Otherwise, the heavier mass will sink and the lighter mass will rise. But we're not going to talk too much about mass until later on. The first thing we're going to talk about is space and time. Space and time is kind of the canvas in which motion takes place. And so that's going to be important to us, especially early on. So we already said that we can measure space with rulers, but how do we measure time? Of course, you're going to say clocks, but they didn't have clocks until quite late, actually. Earlier forms of timekeeping were not so useful in doing experiments that would be useful for physics, because we're really interested in measuring time durations or time intervals, how long it takes something to happen. Like, for example, how long does it take for this pen to drop from here to here? And for that, you need better ways to do things. And one way that you can do it is with a water clock. So, for example, if you take, can I get an assistant up here? Gabriel, can you come up here and hold this, face the camera, please, so that the camera can see it a little higher. There we go. Try to hold it like this so we can see there you go. Now I poked a hole in the bottom of this, and it will start to drain water at a fairly steady rate. And I'll open the top up, and I can measure how much time has passed by how much water goes into the vessel. Now, of course, I would have to calibrate this, and so I might calibrate things in milliliters, which is what this measures. And I'm just going to stop it right there. So that's about 100 milliliters. And so 100 milliliters is going to correspond to something like 10 seconds in the configuration that I've made here. One of the first kind of calibrations that was done by Galileo, right, back in the 16th century. And he actually used a pulse. He felt his pulse, and that was a pretty good clock. And roughly, it's about 1 beat a second. And so that was one of the earliest ways to calibrate things, and he would calibrate water clocks with that. Later, he started using other devices like a pendulum. He was the one that discovered that the motion of a pendulum, for small angles anyways, is constant. And so it'll swing back and forth like this reliably, and you can use that as a way to measure time. Now, of course, the pendulum will eventually come to rest, and so the period of the pendulum will change as time goes on. And so that, it makes it not perfect, but it still works. Later forms of timekeeping, kind of a modern form of timekeeping, is using a quartz crystal. Quartz can be turned in, you can make a tuning fork out of a piece of quartz if you cleave it just right, and this will resonate at a certain frequency. And you can design it so that it resonates at a certain frequency, and they do that, and they have electronic means in which to translate that periodic ringing that it would make into a reliable 1 second time interval, and they can use that to move the second hand on a clock. So how do we know what we know? Well, we measure it, and the way that we measure it are in some of the ways that I've described here. So in the next lecture, we're going to talk about a quantity that you have to make 2 measurements to do, and it's a rate of change, and that is velocity.